Good morning, class. I'm going to be posting on YouTube some of the solutions of the exercises that I've given you previously regarding magnetic fields derived from currents. The first of which is this. At a certain location, Earth's magnetic field is 31 microtesla and it's horizontal. So let's assume this is the terrestrial field, Earth's magnetic field. And let's assume this is whatever they're talking about, horizontal and due north. So this is our north. Suppose that the net field is zero at that point. The net field is zero, then that must mean there should be another magnetic field which equates that and opposite to it. And that should come from a wire. They said, suppose that the net field is zero exactly 9 centimeters above a long, straight horizontal wire. So we have two magnetic fields such that the resultant is zero. So that must mean they are opposite to each other and equal to each other. What is the magnitude of the current that would give such a result? To start with, we have to say that the resultant field is zero, and the resultant field is nothing but B wire and that of Earth. So that must mean that B wire is the same as B Earth, and B wire is nothing but mu 0 over 2 pi I over D is given by B terrestrial, and they've said that this is 31 microtesla. So now mu 0 is given as 4 pi times 10 minus 7, the permeability of vacuum or air in this case. 2 pi, the distance is 9 centimeters, equals to 31 microtesla. So you'd end up having I whatever amperes. Okay? Now about the angle between the current direction and due north. Well, this is a bit tricky, and they've said that Earth's magnetic field, B terrestrial, is directed due north. So that must mean that at this point, the magnetic field coming from the wire must be opposing it and acting as such. Now, what current, excuse me, would create such a magnetic field? We know that we have a wire that carries this current, and the wire must be placed as such. And the reason is, if the wire is placed as such and it carries a current from your left to your right, then if you follow the right hand rule, force your thumb to be carrying that current over here, and the magnetic field would spiral through, right, and comes as such. So this would be the magnetic field coming from the wire according to the right hand rule. So that must mean the current is directed that way. So the angle between the terrestrial field and the current should be 90 degrees. Alright, that's it for the first problem.